Alright, section 1.3, exercise 60. Now, this one, they're getting us actually ready for chapter 2 when we look at something like this. The limit as delta x goes to 0 of x plus delta x squared minus x squared over delta x. And what we see when we look at this is, again, we have a 0 over 0 problem here, because if I do a direct substitution of delta x equals 0, the bottom is definitely 0, and the top is x plus 0, which is x squared. So I get x squared minus x squared, I get 0 over 0. Okay, so that's a problem. So what we can do is just multiply everything out on top and see what happens. So perfect square, I get x squared plus 2x delta x plus delta x squared minus x squared all over delta x. The x squared minus x squared is 0, so I end up with the limit as delta x goes to 0 of 2x delta x plus delta x squared over delta x. And once again, notice I've got a delta x there and a couple of them there that are multiplied by each other. I can factor one out. So I have the limit as delta x goes to 0 of delta x over delta x times the limit as delta x goes to 0. And what I had left on the bottom was just 1, so there's nothing left down there but a 1. On top, I have my 2x plus a delta x. But now, again, we're using this nice thing here that's just 1, and then by direct substitution we get our 2x plus 0 by our direct substitution, and so now we just get 2x. Now I'm going to do this again in that the author does the delta x thing, but in so many ways it's nicer to use h in place of delta x. And so you could write this as the limit as h goes to 0 of x plus h squared minus x squared over h. So you see it's still 0 over 0, works the same way. It's just much nicer to write, you know. So I get my x squared plus 2xh plus h squared minus x squared over h. The limit as h goes to 0. Now we've already done this, so I'm going to skip to the h over h and limit as h goes to 0 of 2x plus h. And so again we get 2x out of that. Okay, so using h in place of delta x is a very common thing in mathematics. The delta x is kind of nice, you know, it's a small change in x, that's a nice thing to think about. But h is also a small change in x. I mean, you know, that's how I'm using it here is just that, you know, I started at x and I added a little something. Or subtracted, because h could be negative as h goes to 0. Alright, so that was number 60.